Hi, this is SPM past year questions of the chapter Circular Measures, which is chapter 5 in Form 4 Additional Mathematics. And in this part 2 video, we are going to look at paper 2 questions. So question number 1. Diagram shows a sector BAC here, so meaning that BAC is a sector with center A, and sector AOB with this, okay, this one, with the center O. It is given that OA is 17. So from here to here is 17. AB is 8.8. AB is 8.8. Find the angle of OAB in radian. So first thing, since AOB is a sector with center O, means OA and OB are the radius of this sector or AOB. So if they are radius, meaning that they have a same value. So if we look at the triangle AOB, when they have the same values of these two sides, this is an isosceles triangle. Hence, this angle and this angle has the same value. So 180 minus 30, to find this angle here, so the angle of OAB, 180 minus 30, and divide by 2 since these two has the same value. And you get the answer. 180 minus 30 is 150, so it's 75 degrees. But the question asks to give the answer in radian, so we change 75 degree to radian form. Question B. The perimeter of sector BAC. The perimeter of sector BAC means we are looking for this plus this plus this, the arc length. So this part and this part is the radius of this sector. Since AB is given 8.8, meaning that from here to here is also 8.8, since both of these are radius. Now the only thing we need to find is the arc length. To find the arc length, we use the formula S equals to R theta. R will be radius, theta will be this angle which we just found it in question A. So now we find BC first. Okay, so the arc BC equals to R theta, R significant figures 0.52. Hence, the perimeter final question. Find the area in centimeters squared of the shaded region. So the shaded region is actually we can divide into two parts. First is the area of sector A or B. The first area, area 1, and the second part is this area, area 2. Area 1, we can use the formula, area equals to 1 over 2 r squared theta to find area 1. And area 2, we first find the area of the sector A or B, and then we minus the area of the triangle AOB. So to find area 2, area 2 is actually, so area 2, this part here, is actually the area of the sector AOB minus the area of the triangle AOB. So first we use the formula 1 over 2 r squared theta to find the area of the sector AOB minus 1 over 2 r squared sine theta, which is the formula to find the area of the triangle. And actually this formula comes from 1 over 2 AB sine C, where you will learn in the chapter solution of triangles. 1 over 2, we factorize this, you get theta minus sine theta. And R is the radius of this sector, which is 17. Theta is the area for 2. For area 1 is actually the area of the sector ABC. So area 1 the answer is 50.68. Hence, when you add these two values, you get question number 3. Diagram shows a semicircle PTS. So PTS is a semicircle, means from here to here. Okay? PTS is a semicircle with center O and radius 8 cm, means from O to S is 8, from O to T is 8, from O to P, from here to here is 8. QST is a sector of a circle. QST is a sector of circle, so here this is a sector with center S. And R is the midpoint. R is the midpoint of OP. Means here is 4, and from R to P here is 4. Calculate. A, the angle of TOR in radian. The angle of TOR in radian. You are given a right angle triangle here. We can use trigonometric functions to help us. So if we are looking for this angle, this side will be the adjacent side, and this will be the hypotenuse of the right angle triangle. So the trigonometric function involved with adjacent side and hypotenuse is cosine. Hence, for A, we can use cosine to help us. Okay, so the cosine of the angle TOR, which is this, is equals to 4 over 8. Adjacent angle over hypotenuse, which is 60 degrees. Hence, we know that here is 60 degrees. B, the length in centimeter of the arc TQ. TQ, the arc, we are looking for the length of the arc. So in order to find the arc, there's one formula, which is S equals to R theta. Okay, so if we can use the R theta, we can find this arc length. Okay, so if you want to use R theta, R will be the radius from here to here, or from here to here. So if you want to find the length of the radius, from here to here is 8, here is 4, but the problem is QR. We don't know the length of QR, so we cannot find the radius from here. How about this length? We can use, since this TRS is also a right angle triangle, and since we know this angle, we can find this side. And if we can find this side, we can use Pythagoras theorem to find TS. Okay, let's try it this way. So first, from this triangle, you use the Pythagoras theorem, we can find this side. Or you can use cosine rule, either way. So I use Pythagoras theorem to find TR. So TR. Now I know that TR is the square root of 48. Then I can use this side and this side. Again, with the Pythagoras theorem, I can find the hypotenuse TS. 13.86 means I know that the radius here now is 13.86. If we can find the radius, then we get the radius. Now we are looking for the angle. So for this sector, the angle is here, the theta is here. So since we know that this is 60 degrees, 180 minus 60 you get here is 120. And since this here is and this here are radius, they have the same value. Hence, this TOS is actually a isosceles triangle. This is an isosceles triangle, so we know that this angle and this angle has the same value. I know that this is 30 degrees, so now we have the second information. We can find the arc length. So the arc length of TQ equals to R theta. So the arc TQ has a length of 7.258. Now we get to the final questions. The area of the shaded region. We are looking for the area. So it's quite obvious that we need to first find the area of the sector. Since we already have the R and the theta, base times height. So the base here is 12. Height will be the square root of 48. .729 centimeter squared. Question number 4. Diagram shows a semicircle AEB. AEB is a semicircle with center O and quadrant of a circle DCE. Quadrant of a circle DCE. So quadrant of a circle is actually a sector. Since it's a quadrant, so the angle subtended by the sector is 90 degrees. Okay? So just for example, this is a circle. A quadrant means this divided by 4, and then this is one of the quadrant. The second quadrant, the third quadrant, the fourth quadrant, one of the quadrant of the circle. Hence it will be 360 over 4, 90 degrees. Calculate the value of theta in radian. So theta is here, we want the theta in the form of radian. So there's no information that we can get from here. Hence we can use the adjacent angle to help us to find theta. Because the adjacent angle is related to a right angle triangle. Since this is 90 degrees, hence 90 degrees. So again we can use a trigonometric function. This is the opposite side of this angle, and this is the hypotenuse. So we use sine to help us. If this is 30 degrees, 180 minus 30 degrees, hence this is 150. But in the form of radians, so theta equals to now we try to look for the perimeter of the whole diagram. To find the perimeter of the whole diagram means we are looking for all of this. All of this. So we can start off with finding the radius from A to O, which is A to O is the radius, O to B is the radius. So since EO is also a radius of a semicircle, 5, which means OB is also 5, AO is also 5. Then we look at DA. Since EDC is a sector or quadrant of a circle, means EC is the radius of this circle, and DC have the same value as EC. So DC is 2.5. However, DC and AO overlapped at AC. So we still need to find the value of CO. To find CO, we just use the Pythagoras theorem. So now we have all these are done. Now we look at the arc length DE. So since we have a radius, we have the angle. We can use S equals to R theta to find DE. So DE is solved. Now we look at EB. We have the angle. We have the radius. Again, we use the angle. We can find EB. Hence, we have all the information now. We can start. Now we look at the last question. The area in centimeter of the shaded region. First we need to find the area of the sector where we use the formula, and then we need to minus this part EAC. So first we need to find the area of EAC. In order to find the area of EAC, we need to find the area of this sector minus the area of the triangle. Okay, so C, to find the area of EAC, first we need to find the area of the sector EOA minus the area of the triangle ECO. So the area of the sector, we use 1 over 2 r squared theta, where the r is the 5, theta is this, which we found this just now, the 30 degrees. We change it to radian. And the area of the triangle is this, where we need to find the length of the base and the height. Oh yeah, we already find CO just now. Here it is this. Then we just write down the values. Okay, so it's 1 over 2 times the base times the height. We have found this area, which is 1.133. We just need to find the area of the sector and minus 1.133. So area of a sector ECD is actually, by using the formula 1 over 2 r squared. R is the radius here, which is 2.5. So it's 2.5 squared. And the angle is 90 degrees, so 90 times pi over 1. You get 3.776 centimeter square. That's it. Thank you very much for watching.